We're looking at the free response section of the Chapter 3C practice test. First question, there's some instructions. We're going to read them. It says, Joey appears to be growing slowly as a toddler. His height between 18 and 30 months of age increases as follows. So we see his age, his observed height. Predicted height, there were a couple blanks on your paper, and residual, there were a couple blanks on your paper. It says the least squares regression line fitted to this data has the equation height is 61.5 plus 0.837 times the age. Question 9 says finish filling in the table above. So you can see I filled it in already. The concept for how I figured this out, if you have observed and predicted and residuals, well, you should know that residual is the actual minus the predicted. So this number minus this number gives you the residual. So if the residual is negative, this number would be higher than the observed. So basically I just added 0.08 to this number to get that. The residual for the second one, 78.7 minus 79.09, would give you negative 0.39. For the next one, 84.8 minus 84.11 would give me a residual of 0.69. And the last one, again, if you have a negative residual, this number's higher. So 86 plus the 0.62 would give you 86.62 for the predicted height. Question 10 says that we need to sketch a residual plot on the axes provided. So again, your residual plot, always the middle should be just the x-axis, the line y equals 0. The scale that you're going to use is based off the size of the residual. So I see the biggest residual I have is about close to 0.7. I have one that's close to that positive and kind of close to that negative. So I'm going up to 0.8 on the positive and negative 0.8 on the negative side. So basically I just made each block 0.2. And on your x-axis, you can see I have 74, 76, 78, 80. That's the heights of this child. So for the first one, the height of 76.5, the residual is negative 0.08. That's a little bit below the line. 78.7, that's over here. Boom, negative 0.39, that's really close to negative 0.4. The next one is 0.4, and that's at 82. So 82, I went up to 0.4, etc. I have two more points. So that's what my residual plot looks like. Question 11, based on your residual plot, would you describe Joey's growth pattern from 18 to 24 months as linear and explain? So I said there's not really a fan or a curved pattern. And so, this is generally a scattered plot. You have some points that are below, you have 3 that are below and 2 that are above. You have some points that are above and below. It seems to be a random scatter, so I think that the data is linear. A curve, you know what a curved pattern would look like. A fan is when the data starts really close together and then it fans out. Or it could start really spread out here and get less and less spread out as you get this way. So it could curve in from the top and curve in from the bottom. That's another way you could have a fan pattern. Question 12 says, according to the least squares principle, which is the total sum of the squared residuals, and you can use the list editor on your calculator to help you find them. Which of the lines below provides the best fit for the data shown in the scatter plot? So here is our scatter plot. And, you can kind of see here, I was thinking about sketching a line through the data points and just to see what I would get. And in general, I'm not really sure if this is the best line because it gives me 2 positive residuals and these 2 points specifically one. I think maybe a better plot might be along this line that I'm tracing. So if I follow that up, I hit about 2. Oh, here's our data points. Let's just try putting these data points in the calculator and seeing what the regression line we would get. would be. So I'm going to go to Stat, Edit, and I'm going to clear out my lists of the data that I have in there. All right, -1, 1, 1, 3, 5. And on Y data, 2, 0, 1, -1, and -5. And so once we have this data in our calculator, the least squares principle, the concept here is what you want to do is find the residual for each of these lines, or let's just say we start with the first line. We want to find the predicted y values based off this line, and then we're going to do the residual, which is the actual y value minus the predicted one from that line, square it, add that all up, and we're looking for the smallest total amount. So what we're going to do first for list 3 is we're going to take, in list 3, we're going to put 2 minus the x values. So 2 minus, and the x values were list 1, so we're going to hit second 1. So it says 2 minus list 1. So these are all the y values based off choice A as the regression line. And then what we're going to do is essentially we're going to do 2 minus 3, square it. 0 minus 1, square it. 1 minus 1, square it. -1 minus -1, square it. -5 minus -3, square it. And then add that all up. So the way we do that, and we're going to go back to the main screen, is since we're adding stuff up, we need a sum. So we're going to go second stat, and we're going to go over to the math menu, or do the sum, and we're doing the residual. So the actual value minus the predicted. The actual y values were in list 2, so we're going to hit second L2, minus the predicteds were in L3, so second 3, close your parentheses, and we're squaring them. And then we need to close our second parentheses. Hit enter, and this gives us 6. So this number, this first value is 6. That's the least, so the least squares principle. That's the sum of the residuals squared. Then we're going to check B and see what number we get for that. So we're going to stat, edit. This time in list 3, we're going to do 1.5 minus list 1. Come back to our main screen, and we're going to do the same calculation again. So second, enter. This time we get 3.25. So that means that B is a better choice than A, because the least squares principle, you want this to be as close to 0 as possible. So B is better than A right now. Then we're going to go back to stat, edit, and we're going to look at now choice C, 1 minus x, 1 minus the list 1 values. Go back to your main screen. We're going to run this command again. And this time we get 3, which is an even better choice than B. So right now our answer would be C. Let's keep looking. Let's try D. Stat, edit. We're going to change this list now to 3 minus 2 times list 1. Go back to your main screen, pull up this command again. This time we get 18. That's a terrible line. It's much farther away from 0. So we know it's not D. We're still going to go with C at this point. Stat, edit. Now we're going to try the final equation. 3 minus 1.5 times list 1. Back to your main screen, pull up the command one final time. We get 9.25. So again, this is not our best answer. Our best answer is the lowest number that we got for this. So that means C is the correct answer. I know I have B on here. I did the problem wrong when I did it. But C is the correct answer for number 12. Going on to number 13. It says anthropologists must often estimate from human remains how tall the person was when alive. Carla is studying how overall height can be predicted from the length of a leg bone in a group of 36 living males. The data show that the bone lengths have mean 45.9 centimeters and a standard deviation of 4.2 centimeters. The overall heights have mean 172.7 centimeters and standard deviation 8.14 centimeters. And the correlation between bone length and height is 0.914. Part A says to determine the equation of the least squares regression line of height on bone length. Show your work. So in order to get the least squares regression line, we need to calculate the slope of the line and the y-intercept. So the slope is the correlation times sy over sx. The correlation was 0.914. The standard deviation of y is 8.14. Standard deviation of x 4.2. If you type that in your calculator, you are going to get 1.7714. That's the slope of your line. The next thing we need to calculate is the y-intercept. And the y-intercept is calculated by doing, we did this on the board in class last time, it's y bar minus this number b times x bar. So we're going to go over to the calculator and do that because I don't have it written on that paper. So first we need to do y bar, which is 172.7. We are going to be subtracting the b value, which is 1.7714. 1.7714. And we multiply that by x bar, which is 45.9. And we're going to call this an a, the variable a, so we're going to store it as alpha a. So that means our y-intercept is 91.39. And again, our b value was 1.7714, that's our slope, so I'm just going to store that as letter b. Alpha. Okay, so that means essentially that our equation is a plus bx. And I'm going to type y1 bars over to y bars, y1. Ooh, that's because that's not what I wanted to do. A plus bx, where a is 91.39. So the equation, let me type it in manually. We got alpha y. Y, we're going to say equals, so I'm just going to put a dot. This is representing equals. So we'd have 91.3927. And our b value was 1.7714, so plus 1.7714x. This is your equation. Y equals 91.3927 plus 1.7714x. You can see over here I didn't write that whole equation because I didn't finish the problem. But this is what the equation should be on that paper. B says that we need to interpret the correlation in the context of the problem. So the correlation is, interpreting the correlation is talking about r squared. So r squared is 0.914 squared, which is 0.8354. And then the interpretation of that is just that sentence that I told you guys you need to remember, which says that 83.54% of the variation in overall height, the variation in the y variable, is explained by the least squares regression line of overall height on leg bone of y on x. And the last question, in general, is correlation a resistant measure of association? The answer to this question is no, and explain briefly or give an example to illustrate. Correlation is not resistant because it is affected by outliers. It can be strongly affected by outliers. Outliers affect the slope of the least squares regression line, and correlation varies directly with the slope. The correlation varies directly with the slope. If you change this, if you change correlation, if you increase it, the slope goes up. If you decrease it, the slope goes down. because it varies directly with the slope.